Enhanced Electric Power Quality and Reliability, Lesson 8, Data Historians and the Pi System. So now we've spoken about the needs for a time series data historian, so today we're actually going to start looking at a specific data historian, a specific application or product suite that is produced by a company called OSIsoft. And we're very fortunate at Palm Beach State College that OSIsoft has donated a Pi system to Palm Beach. And so we've done some system integration work, and we're actually collecting data from electric meters in the on campus, and that data is now stored in the historian for you to use. But we're going to start talking about some specifics of how the data gets in there. And I want to jump right in. So typical Pi system, we've talked about system integration, right? And so let me put this in the framework of what we've already talked about. So your data source here, this is our SCADA system, right? So SCADA system produced by a vendor. That SCADA system is going to have some sort of an API or an SDK or some sort of way for us to get data in and out of that system through into third-party systems, right? So in our previous examples, let's see, we have a firewall here, and so this is our SCADA network, and this is our corporate network over here with all of our desktop computers and all that stuff on it. So in order to collect data into a Pi system, into our data historian, what we're going to do is we're going to introduce an interface node here. Okay, and this interface node is going to run some Pi software, and it knows how to talk to a proprietary system. Okay, now we've talked about some ways of doing this in a previous lecture, and one of the things that we talked about was an OPC server, right? So it could be that our SCADA vendor has an OPC server that talks our private API SDK, our proprietary API SDK on this side, and then talks OPC outside. And so in that case, our interface node would be the Pi OPC interface that knows how to talk OPC, and it would go talk to this server, which would get the data, and it would report it back to the historian. But one of the things that OSI has done, we talked about these APIs and how one of the bad things about it is that there's so many of them and there's so many different control systems. And one of the things that OSI has done over the past 25 years is they've written in excess of 400 interfaces using these proprietary APIs and SDKs from different vendors. So when you buy a Pi system, you can go buy a Pi interface that will talk specifically to the control system that you have and report the data back into Pi using one of these 400 interfaces that they've developed. Or you could use the common language here, the OPC, and you could get the Pi OPC interface, and then your vendor probably has some sort of an OPC server or offering that they provide that you can buy from them. And so now you've done your system integration, you've got your interface node here, and that interface node is going to put the data in your data historian in your Pi server, and now your client PCs can go get that data. So inside that API node that I just showed you, inside that interface machine, here's what's happening. You got your data source. The Pi interface speaks to that data source either through OPC or through the proprietary API. And then it's got something in here called a buffer service or a buffer subsystem. And what this is it's kind of a temporary database, so that if for some reason your Pi server is not available, maybe your network goes down, maybe you have to do some maintenance, you come in on Saturday night or whatever and you do your maintenance in the middle of the night so that you don't bug your users too much. This interface node has the capability of buffering the data so that your users on this side won't be able to connect to it in real time, but when they come in like Monday morning, if you shut it down on Saturday night, when they come in on Monday morning, the data will have been buffered while that Pi server is down, and then it'll be restored. So this is what an API node looks like on a Pi system. And again, it's just a computer running a program that knows how to talk to the control system that then reports that data to your data historian, your Pi server. And so again, remember from previous discussions that what we're collecting here is tag information. So we've got our instrumentation in the field, okay, and what we want to do is get those instrument readings into our Pi server. And each one of these readings is stored in a tag. It's identified by a tag. So like right here, I have my tag name, and I've got my value, and I've got my historical information. But that's the overall goal of this, and it's important to keep that in mind. Let's talk about the data flow. What happens when the data gets into the Pi server, right? So our API node, or our interface node, collects the information from the Pi system, and then it's put inside the Pi system, it's put into something called the snapshot table. Okay, so one of the important things that we want to know with any system like this is, what is my current value? And so what the snapshot table does is, for however many tags are in the Pi server, and a Pi server can be anything from 500 tags up to about 3 million, I think, is the maximum supported value. But of course, you could have multiple Pi servers. So if you have more than 3 million tags, what you have to do is you just have to apportion them amongst several Pi servers. But the snapshot table is going to have anywhere from, say, 500 to 3 million tags in there. It's going to have the current value, whatever the latest value the API node reported, and it's going to have the timestamp. So if I go pull up a screen and I want to look at values, and I've got a bunch of current values on that screen, the data comes out of the snapshot table. Okay, so this is getting updated about as fast as I can update it. As fast as these things can send me data, I want to update my snapshot table. Now after that, as new values come in, what I want to do is I want to evaluate them and determine which values are going to be put into my archives. Okay, so my archive is my historical record of values for the tags. So like right here, I've got my tag reading for my sinusoid tag, and I've got all my old readings in here. So I can go back and reconstruct a history of that sinusoid tag now if I want to. So as things are coming in here, I'm compressing the values and then putting them in the archive. And we've already discussed how this compression works, right? So we do a couple types of compression. We do exception compression, where we say if it hasn't changed since the last value, I'm not going to take a new reading. And so I can do exception reporting here. I can do my exception compression here, right? So I can say if the value hasn't changed, I'm not going to update my timestamp. I'm not going to update it here. Okay. Now when it starts changing dynamically here, I can use my swinging boxcar algorithm, and I run that here to decide what records get put in the archive. And you can remember that the reason that I want to do this is because of storage, right? I don't want to store more data than I absolutely have to, because it uses up disk space, which disk space is cheap these days. But I also want performance. So I don't want to put, if I can spell performance there while I'm talking. So I want to have good performance. I don't want to put so many readings in here that when I go to retrieve my historical data, I've put so much in there that it takes forever to read it off the disk. And so my compression here saves me in storage requirements, and thus provides me with better performance as well. And again, this is using the swinging boxcar algorithm. So my data types, okay, and we've talked about tags, and my tags can be of different type. Okay, whoa, I need to make that into a pin there. It's trying to draw squares or rectangles on the screen. So my tag values, they can be numeric, which most of them are going to be numeric, right? Things like temperature readings, voltage readings, current readings, things like that are all going to be numeric. I can also be saving strings, so maybe somebody, maybe there's something in the system that I need a string, like who was the last person to modify a value or something like that, and I want to put their name in a tag. It can also be a timestamp, so maybe I've got a tag that has the value, maybe the last time an event happened or something like that, and so that tag holds a timestamp. And it can also be binary, so I could have something like a switch was opened or closed, or a valve was opened or closed, or I could have like the mode of something. So maybe I've got some sort of controller and I can put it in manual or auto or program or cascade or program auto. So I've got different types of data types that I can store in there for my tags. So again, this is talking about our exception reporting, and